Hi everyone, just wanted to take a moment to talk a little bit about the next part of quadrilaterals. This is going to be the second half of our quadrilateral activity. So we're going to be dealing with trapezoids and kites on these ones, and these are kind of the other branches of the main quadrilateral family, right? We had parallelograms that we talked about last time where we had two sets of parallel sides. So this side was parallel to this side was parallel to this side. Now we're going to have trapezoids and kites, which will have less parallel sides. So what is our goal for the day? So we're going to be talking about different types of quadrilaterals still, and we're going to kind of compare and contrast them with all the other quadrilaterals. So kind of keep the other ones in mind as we're going through these. So what's a trapezoid? So a trapezoid is going to be a quadrilateral, so it has four sides, with exactly one pair of parallel sides. So now before in the parallelogram, we had two sets of parallel sides. These two were parallel, these two were parallel. Now we just have, let's say, these two. In theory, it could be these two, but usually the way you draw it, it's these two are parallel. And the two sides that are parallel are called the bases. The other two sides will be called the legs. So it's kind of similar to the isosceles triangle properties, right, with legs and bases and things like that. It'll have two sets of base angles as well. So this will be a base angle, and it'll have this as the other base angle. And then these two up here will be base angles as well. Okay, so it'll have two sets of base angles. So to kind of clearly lay that out, on this slide I have the kind of the shorthand definitions. The bases are the parallel sides, the legs are the non-parallel sides, and the base angles, those are going to be two angles made by a base and the legs, right? So here's my base. Leg 1 makes this angle, leg 2 makes this angle. These are base angles. Leg 1 makes this angle, leg 2 makes this angle. These are base angles. And you kind of look at them in pairs. All right. One important piece of information about trapezoids is that they have something called a midsegment, which connects the midpoints of the legs. And it has a special property. The length of the midsegment is equal to half of the sum of the two bases. So I add the two bases lengths together, divide it by 2, and I get the midsegment. So just like the triangle midsegment theorem. All right, so for example, if I'm trying to find WV, that is equal to 5.5 plus 12.9 over 2. What does that end up being? Well, that makes WV equal to 18.4 divided by 2 is 9.2. So the length of WV is 9.2 using the midsegment property. You might also hear the word median. I personally use midsegment, but for whatever reason, there's not a consensus on this. All right, so let's solve. We have to solve for x. So we know that 2x minus 13 is equal to x minus 3 plus x minus 1 over 2. So 2x minus 13 is equal to, and I'm going to bring these all together, 2x minus 4 over 2. So 2x minus 13, right? The 2 cancels and that becomes 2. X minus 2. Subtract that, I get x. Bring that over to the other side, I get 11. And there you have it. So you can use these to solve some different problems relating to the length as well. All right. There is one more important thing to consider about isosceles trapezoids. About trapezoids, is if the legs are congruent, we have something specifically called an isosceles trapezoid. So that would be if the two legs are congruent, and it has a special property. It creates, well, other than the fact that the legs are congruent, the angles, the base angles, will be congruent to each other as well. So this angle is congruent to this angle, and then this angle up here is congruent to this angle up here. So that's one of the properties relating to isosceles trapezoids. Additionally, you could use the fact, by the way, that if you know these are congruent, you know it's isosceles. Additionally, the diagonals will be congruent as well. So this length is equal to that length. All right. Now, so we have to solve for j, and it's telling us that BAD is 2j minus 3. We know that ADC is j plus 2. Well, this is simple enough, right? We know that these are base angles of an isosceles triangle, so they are congruent. So I just will set them equal. Don't ask me why it's j, by the way. It just is. J equals 5. Oops, that's the worst 5 we've ever seen. 5. Now I can plug that in. That would make each of these be 7. 7. It's not a very interesting base angle, but it is. All right, last quadrilateral. These are the ones we're probably going to spend the least amount of time on. They are kites. So kites have no parallel sides. However, they do have this property. They have the property that the top two, the shorter two sides, are congruent, and the two long ones at the bottom will be congruent as well. Diagonals will be perpendicular. Okay, so if I drew the diagonals in, this makes a right triangle, so you can use the Pythagorean theorem. One diagonal, the short diagonal, will be bisected. The diagonal that is not bisected, the bisecting one, the one that's cutting the other one in half, also cuts angles in half. And then finally, these opposite angles will be congruent. Okay, these are the only ones that are congruent. Don't tell me that these ones are congruent. They're not. They're bisected, but they're not congruent. So there's a lot of different information relating to kites, but don't worry too much about them. We're going to kind of have them as a reference if needed. All right, let's do a little bit of practice, and that'll be it. So what do we know about kites? Well, let's, again, take a look back. We're trying to find this angle right here. We know that these two are going to be congruent. So that means if I look at these two, they are going to be the same. So if I call this x, this is also x. What do we know about all quadrilaterals? They add up to 360. So 36 plus 70 plus x, so 2x equals 360. Okay, so what's that? 106 plus 2x equals 360. Minus that, so I get 2x will equal 254. So that would make x, if I divide by 2, that would be 128. No, 127. So we have 127. So each of these will be 127. Right, and that's just because they all add up to 360. All right, now finally, as I said, we know that the diagonals are perpendicular. So this is a right triangle. So if I need to find RH, I can use the Pythagorean theorem, right? I'll just call that C. So that'd be 12 squared plus 20 squared equals R, I called it whatever, RH squared or C squared. So that'd be 144 plus 400 equals, I'll change it to C now, C squared. So that'd be 544. Now, let me check, is 544? Nope, okay. So equals C squared. So let's see what that's divisible by, because I'm gonna take the square root of both sides. 544 divided by 4, 136. So 544 divided by 16 gives me 34. So that ends up being that C is equal to the square root of 16 times the square root of 34, which is equal to 4 root 34. And there you have it. So that's kind of all the things that we're going to talk about in regards to kites. Please let me know if you have any questions, and have a great day.